Okay, we're on page 453, lesson 8.5, exponential and logarithmic equations. Let's look at example 1. 7 to the 3x power is equal to 20. Okay. If I had x squared equals 25, what would you do to solve that equation? What would you do to solve that equation? If you had the equation x squared equals 25, what would you do to solve that equation? You would take the square root of each side, and you would get x is equal to plus or minus 5. You do that because the square root undoes the squaring. That makes sense to you, right? The square root symbol and the little exponent of 2, they undo each other. Well, I want you to remember what we started talking about when we talked about logarithms, that when you have a variable used as an exponent, taking the log is how you undo that, okay? It's the inverse of that operation. So when you have one of these equations where you have an exponent in a position, a variable in a position of an exponent, you need to take the log of each side, okay? It's just like taking the square root. So you write log of 7 to the 3x equals log of 20. You take the log of each side. Now you use your tools that you learned yesterday. What do you do with that little exponent? Where can you move it? To the front. So that's exactly what you do. You move it over here. So it says 3x times the log of 7 equals the log of 20. Now, this is the same objective you had when you were in the 9th grade. We started solving equations that said x plus 5 equals 8. You want to get x isolated. Well, you've managed to get it out of that exponential position and over here into just a product position. Now, what do you think you need to do? It's being multiplied by this. What do you do to undo multiplication? So you're going to divide both sides by the log of 7. So this says 3x equals log of 20 over log of 7. No. That would look different. That would, if it looked like this, log of 20 over 7 would turn into log 20 minus log 7, not log over log. Okay? Thank you for asking that, because that is something that people get confused. Okay, then get your calculator out. Log 20 divided by log 7.
Where's log at?
Log is underneath x squared. And that's what that equals. So 3x equals 1.53950185. Now we're not done until we figure out what x equals. What's left to do? Not until we divide by 3. So x is equal to 0.5132. Yes?
Every time I do that, I get a complete, different equation than I do with something.
Look here. You got to close your parentheses. That's what's messing up. Okay. Can we do this? Let's do another example. 3 to what power equals 4? 3 to what power equals 4? Well, we all know that 3 to the first power is what? 3. 3 to the second power is 9. So it's somewhere between 1 and 9, right? What's 3 to the first power? 3. What's 3 to the second power? 9. 4 falls in between 3 and 9, so it's somewhere in there. It's really, really close to 1 is what it's close to. But I don't know exactly what it is. So I want you to take the log of each side. Then what do you do with that x? It moves over. So x times the log of 3 equals the log of 4. Divide by the log of 3. Everybody paying attention this morning? Log of 4, close your parentheses, divided by log of 3, and x is 1.2619. 4 decimal places is the standard thing. Okay, let's do another one of these. 3 to the x plus 4 power equals 101. We're going to take the log of each side. Since you don't have a base, base is 10. Base is 10 anytime we do this. We don't write a base, it's 10. I'm going to. I haven't yet. I've taken the log of each side, and the next thing I need to do is take that and move it over there. Divide. This time it says x plus 4 equals whatever we're going to get when we do this. I get this number. And then what do you do to finish this out? So x is equal to 0.2009. Questions on those? Okay. Next thing we're going to do, we're going to split this lesson. We're just going to do a couple of things. We're going to move over and do example 6. It says log of 3x plus 1 equals 5. Now they're giving you an equation. Already has a log in there. Okay, the first ones we looked at today didn't have any logs in there at all, so you did that to both sides. You took the log of both sides. Well, they already have log in this one, so that's not the strategy we're going to use. But what is the base in this problem? 10. So we're going to use what we learned at the very beginning of this logarithm section, and we're going to drag the 10 over it. It's going to pick up the 5. 10 to the 5th equals 3x plus 1. Now you have just a simple equation to solve. 10 to the 5th power is what? 100,000. And then we need to subtract. So what are we going to get here? That's my value for x. Once you take that and can you do those? Those look simple? I think that's pretty easy. Okay, there's one more thing I want to show you. Yeah.
But if there's a number on the log.
If it said 7 right there, then you do 7 to the 5th power, and whatever that number would be, and then you go on about your business. Once you get rid of the log and you just have a basic equation, you just use basic equation rules. Okay, example 7 says 2 times the log of x minus the log of 3 equals 2. You really want to condense this. This is expanded. You want to condense it to where you have one log, and then you can go about solving it. So you're going to do what you did yesterday. We're going to put this left-hand side back together. Where does the 2 go? So the first step is to write log of x squared minus log of 3 equals 2. Then take these two and we're going to combine them. How does subtraction translate? Division. So this is log of x squared over 3 equals 2. Do you have any questions so far?
Why isn't it log 3 instead of just x squared?
Because subtraction translated into division. Okay? Now you're at the same point we were just a few minutes ago, where you need to take your base, drag it over, and pick up your exponent, and set it equal to what you're taking the log of. And then you just finish the problem. That's 100 equals x squared over 3. What do you do next? So that's 300 equals x squared. Take the square root of both sides. X is equal to, you can put it in your calculator or you can break it into 100 times 3. Just remember that you have two answers here. You have plus minus when you take the square root. As a method of solving an equation, you're going to have plus minus. So it's plus minus 10 square roots of 3, or you could put it in your calculator, plus minus 17.32. Let's do one more of this type. Log 6 minus log 3x equals negative 2. Subtraction translates into division. So this is log of 6 over 3x equals negative 2. And then what? Okay. 10 to the negative 2 equals 6 over 3x. What's 10?
Where did you get the 10 from?
Whenever there's no base written, it's assumed that there's a 10 every single time. 10 to the negative 2, what's that? Fraction-wise, what's it going to look like as a fraction? 1 over 100 equals 6 over 3x. So 3x is equal to 600. Divide by 3. X is 200. Okay, for today, page 456. We're going to do what we did yesterday is going to show up right there for you to practice, okay? I also want you to do 114, 116, and 118. That's also from yesterday's assignment. I mean, it's on this page. It's a review problem from yesterday's assignment. Okay? And then I'm done. I won't put anything else on there. Okay.